Let's look at a simple ladder logic example. In this case, I have a light gate which is separating the outside of the room from the inside of the room. So here I have my person who wants to get to the inside of the room. The way I want this logic to work is if you pass through this light gate, you break the beam. When you break the beam, the horn gives off, and it tells you that someone has entered the room. If you want to enter the room without breaking the light gate, then you have an operator on the inside who presses the button and holds it down. When you hold it down the button, the light turns on. That tells the person on the outside it's safe to proceed through the gate, and the horn will not go off. Ladder logic for this, we begin with our rails, plus volts, ground. So one thing that happens is if this light sensor is broken, I want the horn to turn on. So I'm going to write this as normally open. This is the gate. This is the horn. So as wired, it says if the gate is in its nominal state, the horn is off. This shows that it's open, which means current can not pass through. Now I need to incorporate the button. So I want to have it so that if the button is pressed, then the horn will not turn on. So the conditions are if the light gate is broken and the button is pressed, the horn still will not turn on. And I can do that by inserting button as in normally closed. So now the logic says in the normal state, if the gate is not broken and the button is not pressed, then the horn will not turn on. It's broke. The current can't flow through here. The circuit's broken. However, if the gate is in its not normal state, that is, it's tripped, then this becomes closed, and the button is normally closed because it's not pressed, and the horn will go on. That's what we want, which means someone passed through the gate, the button was not down. However, if the button is pressed down, then it's in its opposite state, so this would be open. Now, if the gate is closed, even though there's current to here, this would be open, and the horn would not turn on. So this gives us the effect, if the button is up, you pass through the gate, the horn goes on. If the button is down, this is now open. Even though the gate is broken and this changes state, the horn doesn't go on. The last part we need is the light. We also want it so that when you press the button down, the light turns on. So if you press the button down, the light turns on. This is an important thing to note here. We have one switch, but I've represented it twice on the ladder logic. And you could do this with a relay. You could have the button connected to a relay that has a normally closed contact and a normally open contact. So if the button is in its normal state, the light's off, no current can flow. If the button changes state, then this becomes closed and the light is on. There is a problem with this system, and it stems from the fact that ladder logic happens instantaneously. So if the user sprints across the gate, then momentarily this closes, the horn goes off, but as soon as he passes on the other side, the gate's back open, the horn goes off. So if you run fast enough, all you hear is a little chirp, and maybe the person on the inside won't notice, so you can get through. There is a way to get around this using ladder logic, and that's using a construction that's called a latch. And that's the topic for another discussion.